my name is Ian Billett. I'm an engineer at Improbable, where I work on our internal platform observability team. And the title of this talk is PromQL for Mere Mortals. And this talk is about the fundamentals of PromQL. It's about helping people out there to develop the right mental models and thought processes that are going to help them really get to grips with PromQL. And this talk is primarily aimed at kind of the newer people in the ecosystem, but I hope that even the more experienced among you can take something away. And so this talk is going to be full of mistakes that I've made, which is good. And if any of you go away from this talk and don't make one of the mistakes that I made, then this talk has been a roaring success. And so this was me maybe 9-10 months ago when I started out with PromQL. And I'm not sure how much has changed since then. So a quick agenda. We're going to start with the very basics. We're going to talk about time series, instant vectors, range vectors, and we're going to use this as a foundation to build up to talking about gauges, counters, operators, functions, and then we're going to tie it all together with a demo at the end. So the first thing to say is that PromQL is important. Queries, alerts, dashboards, anywhere in the ecosystem that requires the retrieval of metrics data will necessarily involve PromQL in some capacity. But at the same time, it's an intimidating technology to learn. This spicy nugget was one of the first alerting rules I had to dig into. And even now, I couldn't easily tell you what is going on there. And in the early days of using PromQL, my workflow was very much just find some queries, kind of mash them together, add some square brackets, and then keep trying that until the console stopped complaining at me. This wasn't a very sophisticated approach and definitely did not demonstrate an understanding of the fundamentals of this language. But in all seriousness, though, PromQL is essential, but that also means it's a barrier to entry to the ecosystem, and we must not lose sight of that. So, time series, first of all. So a time series is a stream of timestamp value pairs, like this, and each time series is uniquely identified by the identifier, and this identifier is a set of key value pairs that looks like this in the UI, which is just syntactic sugar for a kind of I think of this just like a JSON object, basically. So when you set off on your adventure into the PromQL documentation, the first thing you bump into are the 4 fundamental data types in PromQL. These are strings, yeah, we all know what those are. Scalars, weird name, but that's just a float to me. Then you bump into instant vectors and range vectors. What are these? So a brief bit of context now to absolve me of looking like a complete idiot in the next section. PromQL is my 3rd query language after SQL, JQL, although I've never publicly admit to knowing any JQL, and PromQL. And so as a human learning a new skill, it is the most natural thing to take the mental models you have for something else and try to the next nearest thing and try and apply that to the new thing you're trying to learn. And in my case, that was SQL and my knowledge of relational databases. I tried to pick that up and put that in kind of rationalized time series with respect to that, which has kind of hilarious, disastrous, and often frustrating consequences. So, firstly, so this is the definition of an instant vector from the documentation. And I look at that and I think, okay, we have a set of time series, we have a timestamp, and we have a value for each timestamp series pair. So the SQL lobe in my brain kind of starts throbbing at this point, and I immediately think of this. Kind of makes sense, right? We have a set of time series, we have a timestamp, and we have a value for each series timestamp pair. Kind of seems sensible, right? Okay, so range vectors. Sorry, and then this is what the instant vectors look like in the Prometheus UI. Range vectors now. So again, this is the definition of a range vector from the documentation. I read that and I think, okay. We have a set of time series, we have a range of timestamps, and for that range, for each series, we have a range of values. Again, the SQL lobe in my head kind of starts throbbing and kicking in here, and I think of this. So here we have a set of series across the top. We have time decreasing on the left-hand side, and we have a range of values for each time series. This kind of seems sensible, right? So at this point, again, sorry, this is what it looks like in the Prometheus UI. So at this point, I was confused. I was really confused. Given the mental models I described to you, I had some questions. Like, if we had a range vector with only one sample in it, is that actually an instant vector? Are we really not asking, like, what is the difference between an array and a matrix? And this all led me to ask the question of, are they really that different? And the answer to this question is emphatically yes. They are very, very different. And so the problem here was that I was fundamentally misunderstanding the Prometheus data model. I was trying to take the mental models that had served me very well in the SQL and the relational database world and trying to apply them to the time series world. So let me now introduce to you all the way that the mental models that I've constructed for myself to help me really understand the Prometheus data model. And I'm a very, very visual learner, so I hope that this can help some of you as well. So it looks like this. We have a set of time series across the top. We have time decreasing on the left-hand side. And each point here is a value, is a timestamp value in that series. The important thing to notice here, though, is that none of the points occur at exactly the same time. And this is exactly how Prometheus works. So Prometheus will go off to a scrape target, retrieve some data, and insert it into the TSDB. There's likely a lot of these going on at the same time. And none of these scrapes are going to be happening at exactly the same time. So when we have this in mind, thinking about instant vectors and range vectors becomes obvious. Instant vectors, for example, we have the instant, and an instant vector will return to you the most recent sample for each series. And then we look at range vectors. So with range vectors, you effectively give PromQL 2 timestamps, and PromQL will return to you all of the values that occurred between those 2 timestamps. Okay, this could be 0, it could be 1, it could be 10, it could be any number. So to labor this point home one last time, instant vectors, you're guaranteed to get 1 value per time series. And with range vectors, you're going to get any number of values between the 2 timestamps. So with this foundation, with time series, with range vectors, with instant vectors, we can now use this to start talking about more complex topics. So counters and gauges. Firstly, counters. A counter is a value in the time series where the number is only ever increasing. It's going up. It's monotonically increasing, to use a phrase I don't fully understand. And the counter to this is a gauge, and a gauge is a metric value that can go up or down. The tricky thing here with counters is that the instance that is serving this metric to you, if that instance crashes, that counter is going to be reset from 0 and is going to start increasing from there on. And this is going to be important later in this talk. Operators, okay? There are 2 types of operators. The first one is it's the aggregation operators and the binary operators. We're going to talk about aggregation operators first. So aggregation operators only take instant vectors as input, and they only return instant vectors as output. This wasn't obvious to me at the start. So given a time series, a set of time series, the aggregation operator will return to you a new instant vector where the labels of the new instant vector are the ones you told it to care about, and the value at each of those series is the aggregation operator applied to the group of values that you told it to care about. That doesn't make any sense. We'll do a demo and that'll make a lot of sense. And the usual suspects here are sum, min, max, etc. Binary operators. So there are 3 types of binary operators in PromQL: arithmetic, comparison, set operators. These are the usual suspects in programming languages. I'm sure you're all fairly familiar. And binary operators, surprise, surprise, they operate between 2 operands. These can either be scalars or instant vectors. So when we have 2 scalars, the result is a scalar. When we have a scalar and an instant vector, the result is an instant vector. When we have an instant vector and an instant vector, the result is also an instant vector, but this is where it gets spicy, because when you're operating between 2 instant vectors, you need to be very, very careful about the label sets on both sides. PromQL is very, very picky about matching those label sets. And we're going to see this in our demo in just a bit. Functions. There are a bunch of functions available to you in PromQL. they either take an instant vector as input and return an instant vector, or they take a range vector as input and return an instant vector. But there is one function that rules them all. There is one function that will account for 90+% of your use cases in PromQL, and that is rate. So rate is a function which takes a range vector as input and returns you an instant vector as output. And it calculates the per second increase of your counter. Rate must only be used with a counter variable, never a gauge variable. It makes no sense to use it with a gauge variable. And this is the most common pattern you'll see in PromQL anywhere. And you need to get it kind of branded into your brain. It's very, very common. But the rate function is also magic. And the reason why it's magic is because of the way it handles counter resets, like I mentioned before. And what's magic about this is, say for example, you had a target that was exposing a metric, and that went 4.2, and then it crashed and reset 1.3. The rate function would be smart enough to interpret this as 4.679. Okay? So the rate function, using the rate function protects you against inadvertently seeing the world in a way that you're kind of not expecting to see it. This is very important. Okay, so we've talked about counters, we've talked about gauges, we've talked about operators, and we've talked about functions. So now, I haven't sacrificed anything to the demo gods today, so bear with me.
But you have a spoon.
Sorry?
You have a spoon.
I have a spoon, so, you know, it's not all bad. And Brian, please don't take down your testing server. Otherwise, this is going to be interesting. Okay, so the realistic demo we're going to create for ourselves here is we want to figure out, on our CPU cores on our machine, how much time, what proportion of the time is that CPU spent in idle mode? Okay? And so we're going to use this metric here, node CPU seconds total. Okay, and we're just going to inspect this metric, and we see, okay, we have the CPU label, instance, job, and mode label. Okay, so if we want to figure out the proportion of our time spent in a certain mode, we need to take the time spent in that mode, divide it by the time that the CPU has spent running. Okay, and so we would do this. So firstly, we'll figure out how long the CPU has spent in the idle mode. So evaluate this metric here. We'll see we'll have some fairly large numbers here. And like, okay, cool. So now I want to aggregate these metrics such that I've only got the CPU label at the end. And I might do something like this. So if I evaluate this, that's wrong. That doesn't look right. We got a response returned to us, but there's no labels on the left-hand side, and there's quite a large number on the right-hand side. So the problem here is that we weren't telling our aggregation operator which labels we care about. And so if you don't tell it, it just assumes, oh, you don't care about any of them. We're not going to give you any back. And that's exactly what's happened here. So to get around this, what we do is we use the by operator. The by operator tells an aggregation operator, hey, aggregate only by these labels that I tell you. There is a complementary operator called the without operator, which says, hey, aggregate by all the labels without including these ones I'm going to tell you about. So if we just evaluate this query, we can see we get the result that we're expecting. And this seems kind of sensible, right? No, this is not sensible. And this is a very subtle point that took me a long time to figure out. The problem here is that we're summing on a raw counter, okay? And this is a big no-no, because counters can be reset. So you might be inadvertently seeing a state of the world where some of your scrape targets have been reset. And so you could think the state of the world is like it is, but actually something crashed, and you're seeing much lower values. So how do we protect ourselves against this? We use our handy rate function. Rate functions, they know how to deal with counter resets, and you should always use it in this pattern. As I said, the most common pattern you're going to see in PromQL. So we'll evaluate that. That looks fairly sensible. And then we're going to wrap rate function up in a sum function. You always sum a rate, never ever rate a sum. That needs to be in your heads as well. A subtlety, but an important one. So when we evaluate this query, we get the result we're expecting, but also we are robust against counter resets here. Okay, So now we have the numerator of our equation. We need to figure out the denominator of our equation. And so we want to divide this now by the total CPU time. And we're going to take the rate again to be robust. And in this query, we have CPU on the left-hand side, but we're also going to have CPU on the right-hand side. So this is going to work, right? Right? No, this is not going to work at all. The problem here is we're using binary operators. And as I said, binary operators are very, very picky about what labels are on the left-hand side and the right-hand side. On the left-hand side here, we have only CPU label. But on the right-hand side here, we have CPU, instance, job labels. So PromQL doesn't know what to do in this instance. So to get around this, we're going to just apply the aggregation operator to our denominator and tell it to aggregate by the CPU label. We evaluate that, and we get the result we're looking for, whilst being robust to a class of problems that you might otherwise forget about. Awesome. So let me just switch back to my slides. Okay, so just to recap these gotchas in the last demo, tell your aggregation operators about which labels you care about. Otherwise, you might get unexpected results. Number 2, never compare raw counters. Okay, this is a meaningless thing to do because of the counter reset problem. Always wrap them up in rate. Finally, be careful with your label sets when you're using binary operators. Okay. Yeah, you're going to get unexpected results and frustrating results for a lot of the time. Okay, so that's most of what I have to say. Resources for PromQL, the robust perception blog is excellent. The blog posts are short and easily digestible, and best practice, go and look there. The Prometheus up and running book is also excellent, and the documentation, obviously that goes without saying. That's everything I have to say. Obligatory, we are hiring. Everyone is hiring who isn't. Come and talk to me if you want to talk about improbable or anything. And that's it. Thank you very much.
Thank you. Any questions? Oh, there's one.
Hello. So what is the difference between irate and rate?
Between irate and rate? Ooh, I believe irate. So when you have, when you take rate, it gives us the per second average for all the samples in that range. But irate, I believe, calculates the rate between the last 2 samples. Is that right?
Yep.
Okay, perfect.
I can ask a question about staleness in 5 minutes.
Oh,
no, that's not. More questions? Oh.
I've seen a pattern of doing the sum of a rate of a histogram. Do you know what that does? I know that it's something you do, but I've never understood it.
The sum of a rate of a histogram. I'm not able to answer that. Is anyone out here looking at the core maintainers?
I can try to give a quick explanation. Every bucket of a histogram is just a counter of how many observations you've made of that latency category. So a counter, if you tried to calculate quantile from that histogram over all time that counter increased, you'd get like the average over all time, right? Including counter resets, etc. So that wouldn't work. So what you really want to look at is usually the latency averaged over the last 5 minutes or so, right? And so by taking the rate over each of the individual bins, the buckets, you see their relative increases during the last 5 minutes, right? So you get, again, a histogram as an output, but now it's basically over the last 5 minutes. And the absolute values of the buckets don't really matter anymore, because for the quantile calculation, we only care about the relative amounts in each bucket. So that's my attempt at an explanation. Yeah.
Julius just proving he's not a mere mortal.
More questions? Yep.
So I know you folks in Improbable use tunnels, and I believe that effectiveness of PromQL and your recording rules, alerting rules, is somewhat important for you, at least that's what I face in my daily life. How do you assess effectiveness of alerting rules and recording rules, and do you do it at all? And how do you iterate on it?
Gosh, there's a lot to dissect there. So the effectiveness of alerting rules is a topic you could do a whole day's worth of talking on, I think. The alerting rule, I would only point you to kind of alerting best practices, page level alerts only if it's actionable immediately, something that looks bad but can wait till the morning. Sorry. Okay. Effectiveness in terms of...
Take too long,
well, if they take too long, there's kind of not really a huge amount you can do about it. It depends entirely on the amount of data that it's querying on the back end. Effectiveness, I mean, PromQL is tricky because it's not the easiest thing to read and to interpret into Grok. So that's definitely something that is something that kind of needs to be thought about and have things put in place. But I'm afraid I don't have much else to say about that. Any more questions? Hi.
If PromQL is not for mere mortals, what can we do from the documentation perspective to make it clear? Is there anything that we can do?
I mean, PromQL is for mere mortals, clearly, because if I'm using it, then gosh, I'm a flesh and bones human being, last time I checked. So with the documentation, as I said, I'm a very, very visual learner. Like diagrams speak words to me, as it were. I mean, if we could take these diagrams and put them in the documentation, it might have helped me not go through this process that I outlined to you all. Yeah, that would be a great thing. I definitely think more diagrams and documentation is better than less, but that's just me and, can be interpreted in different ways. So there'd have to be a discussion with the community there.
I offer trainings.
I did not really understand what was the number we were calculating with the query there. It was then 0.4 what?
Okay, so the metric we're using was node CPU seconds total. So we were calculating the what proportion of time our CPU spends in idle mode. Because in a CPU, there's a bunch of different modes. There's like interrupt mode, there's user mode, like whatever. And we were calculating the proportion of time we spent in idle mode, basically. And it was not the greatest demo, I think, because the answer we had midway through was the answer we had at the end, but that's just a function of the fact that it's seconds, and when you calculate a per second on a metric that's seconds, you're going to get like the proportion there. But for completeness, if the metric we weren't using didn't have this property, we would absolutely have to do something like that. Something like HTTP requests total, like the proportion that were 500s on a different endpoint, you'd need to do something like that. Cool. Yeah, sure.
Hello, great talk. So me as well as anyone, I think I'm using the rate function for CPU, but I have troubles deciding what interval should I take. For example, I saw that you take 10 minutes, but yes. I want to take 1 minute, but then there are too many spikes. So what are you told?
Okay, that's a really good question. So when you're choosing how long to rate over, the one absolute golden rule you must always follow is the time frame must be at least 4 times your scrape interval in Prometheus. The reason this is because scrapes are valuable, they will fail. And if you're using a rate function, you need at least 2 points to calculate that rate. So Prometheus out of the box is 15 seconds, so minimum 1 minute for these kind of things to get accurate measurements. But obviously, like the longer time frame, the smoother it's going to be. So, it's up to you at that point. All right, awesome.
Any more questions? Yep.
If sum of rate is so common and we need to smooth the curve with the first derivative, is there something Prometheus can do to make the queries easier and faster to avoid that runaround?
So can you make the querying faster? Like, I think that's kind of beside the point. It's going to do the calculation it needs to do. There's an interesting question there about kind of the syntactic sugar of some rate, because that allows you just to mess it up every time if you don't know rate, some rate. What did he say in that talk? I can't remember. So there maybe there is a very good reason, and it doesn't come to my mind now, I think. But yeah, that's down at the PromQL language level, and I'm not quite at that level yet. So awesome.
Oh, there was one. Okay.
How do you deal with metrics that sometimes exist and sometimes doesn't?
There's some metrics that sometimes exist.
For example, the binary operators with metrics that doesn't exist.
Binary operators with metrics that don't exist. So if you're operating between a metric that doesn't exist, you're not going to be operating between it. I'm not sure I understand the question fully there. Come chat to me later on.
Yeah, there's 2 blog posts from Ryan Robust Perception that might be interesting for this. One is called, I think, Existential Issues with Metrics. And I think there's another one using time series as thresholds, which kind of touch that a bit. Like so when some metrics are sometimes missing, you want to fill it up with a default value or something like this.
The more useful blog posts in this case are absent alerting for jobs and absent alerting for scraped metrics.
Oh.
Cool.
Yeah.
All right.
The absent function.
But I think we're out of time. So thank you very much. That
Thank
was
you all
awesome.
very much. Thanks.